All right. Thanks, Tom. Thanks for. I didn't get to see your presentation, but I'm sure I'll get to hear more of the details in here. Thank you for all showing up here. We're going to have a short Q&A. Please think of some really clever questions. Maybe some of you already have. My opening question has several times already today been, having been a speaker myself, you get a lot of like 20 minutes or so, and then you go like, how do I fit it all in there? So what's the subject that you had to cut out because of time?
The subject I had to cut out? Well, so actually probably the commercial strategy, which maybe is about, I talked a lot about like market fit, but actually there's just so much technology going on that's interesting, and if you're doing a speech in a big room with lots of people, they want to see visuals, they want to hear loud sounds, videos. So I normally put those things in and take out the boring stuff that people don't want to hear about, which is how do you make money and all this kind of stuff. We're still working that one out, but we're getting there. We're getting there.
Okay. All right. Anybody have a question? There you go.
I would like to ask if you think that this AI can replace today's CGI in movies, because you showed some of the images, but there is still a big uncanny valley effect seen. So do you think that in the future this will disappear?
Yeah, I mean, right now you're right. Like right now, it's really hard. Like the temporal coherence problem is the thing that it's just without proper video diffusion models that are trained on how objects move in the real world, right? It's just impossible to get that proper representation of physics, things moving, arms moving, liquid flowing. That's something that AI models can't do yet, but it's happening. Like right now, we're training a big video model right now. It's like the thing about training video models is you can imagine you're training an image model, but you're training it on content that's 30 seconds or a minute long, right? For just like one piece of one piece of training input. So the training problem is like an order of magnitude higher, like the data storage, all of these things. But these are problems that are coming down in price very quickly. So yeah, I mean with video models and proper like video diffusion and fine tuning, a lot of these companies, the problem with the video right now is that. One of the other problems is that a lot of the content is behind licensed doors, right? So companies that own that video content, film companies, TV companies, they haven't worked out how to license that data yet. They've always kept it internally, and they're either going to like build their own video models, or they're going to all come together and you're going to create one big video model. But trying to do that and still create an open source model is very difficult. That's something we're working on. But like, I have no doubt that within like a year from now, we'll have 2K video generation, with video diffusion and upscaling. You combine fine tuning in that, you combine the different controllability processes like ControlNet, and you're going to have coherence, right? So reshooting a scene, like where you've got a character in the scene, but you want to change the background and maintain coherence. I can definitely see that happening. Yeah. So. Yeah, I mean, there's already examples of companies that have, reduced the shooting time of scenes from, like $500,000 down to like $100,000 just by using generative AI. Okay, so this is definitely already happening. But I think just the idea that we'll be able to create videos or films that have either ourselves in, so I could like shoot a film, reshoot a scene, but put myself in it, or my kids in it. That's just like an incredible idea, and something that is, I hope will eventually result in just this new form of media, right, where we're being the creator as well as the consumer. So yeah, kind of magical.
I wonder how can we protect ourselves against someone with bad intentions creating fake videos or images to discredit us, or even create fake evidence. If, for example, that combined with hacking into some police systems, surveillance systems, and hack into it the fake video, and even the police with good intentions thinking that we did something that we didn't.
Yeah. I mean, deep fakes have been a problem since long before diffusion models. Obviously, there were deep fake generators with GANs, a year or two ago, some big open source projects, with people trying to shut them down, and then there were even we thought about doing a competition to do a deepfake detector, right? But the problem with building deepfake detectors is that if you build something that can detect a deepfake, you can use that same technology to create a model that's better. Okay, so you can you get in this ping pong situation where you eventually have a race to the bottom where I'm not even sure if it's possible to eventually win that that challenge. There's another way which we're getting involved in, which is invisible watermarking or stamping the image. So Adobe has something called the Content Authenticity Initiative, CAI, and it's basically an encrypted watermark that contains the provenance of the diffusion model or the generation model. You can put the creator's information there if you want. You can put the provenance basically of all of the information. So we've signed up to that, and we through our API, we're just about to launch it, where all the images that come from the stability APIs will have this watermark in it, and the watermark can't be tampered with. It can't be edited. It can't be changed. So it does contain information about the provenance, and that's not so important for identifying the creator, but it's just important for identifying that it was generated, right? What's important is that people can tell the difference between an authentic image or an authentic media and something that's been generated. But the problem with open source, one of the few problems with open source, is that technology can be removed, right? There are always going to be, this is an incredibly powerful technology, and while we're in this initial phase of it, but I don't know how long it will be like this, but while this technology is being changed and evolved, it's going to be possible to tamper with it and always use it to do dangerous things. So I don't know. We're trying to work on that, but having the technology in the open, I think is probably the right way to solve that problem. A lot of deepfake generators, deepfake detectors, these are all open source projects, and having the technology in the open allows people to understand how it works and how to, evaluate it and test it, and that's important for all kinds of things, not for deepfakes, but bias as well, and understanding whether the model is weaker or stronger or has particular ethical bias or something, which is really important. But yeah, it is a problem.
Yeah, but luckily it's a problem, I think, that is already out there for a couple of million years.
Yeah.
Because people will try to fool each other anyway. I swear he said that, right?
Yeah.
That's how it started, and then you say, oh, see, here is something with his signature or with his stamp, and then slowly, look, this is something with his picture, and
Yeah.
see, this is where he did it, and now it's a video, and then it becomes a better video, and then it becomes with sound and smell, and then it's going to be in VR, and you're going to still see him, and so it's been around for 1,000 years, and we won't stop, cheating each other and fooling each other. So
Yeah, probably not.
But it's a rat race. It'll stay there. Yeah. Any questions? This is such an exciting area. Yeah.
Thank you. Yeah, great job on the technology side. It's amazing. I would be interested in what's your views on the, let's say, social or business complications of the controversy that the technology is bringing to, forwards. Like, for example, publishers are starting to ban generative AI work for example, for book covers or something like that.
Yeah.
Do you think this would be a problem, or do you see any feedback loop that will probably bring some benefit back to the creators?
Yeah, I mean, look, so I guess the big thing, right, is licensed data. I mean, everyone knows that Stable Diffusion was trained on the Common Crawl, right? So the Common Crawl basically is, it's a crawl of the internet, 85 billion media assets that are scraped from the internet. And it contains basically it's like what Google used to index the web, it's what ChatGPT is trained on, it's what Stable Diffusion is trained on. They're all trained on derivations of the Common Crawl. The Common Crawl is multilingual, it has hundreds of languages in it, and you can filter it down to images or English or whatever it is. And And so that crawl has been available for years and years and years, and it's obviously being updated all the time. And the problem with it is that it contains copyright information, right? Okay, and it's basically impossible to filter out the copyright information. Because imagine if you license an image from a stock photography company, right? And so you buy it for your website because you want to remove the watermark to put it on your website. So you put it on your website. So there's now when I'm scraping that information, or when I come across it in a common crawl, there's no way to tell that image is copyrighted. There's no information in the JPEG, right, on the EXIF data that says this image is copyrighted. So first of all, like, the landscape of technology doesn't exist yet for machine-readable information to be extracted to tell the crawler, don't use this image. So we need like a no train tag or something, and it could be through something like Adobe CAI that content becomes watermarked or tagged in a way that allows us to do that at a machine-readable level. But that's the first problem. Obviously, all of these models are being trained on that same data, right? So, ChatGPT, you can get it to regurgitate, all kinds of text from copyright sources, and diffusion models, are kind of similar thing. Diffusion models are kind of, they're creating in a way, right? And they do create a little bit like humans create. They blend ideas, they blend styles, they blend things together to create something new. And there are human constructs for things like style imitation that it's very difficult to make illegal, right? Because we don't want to make it illegal for someone to copy a style, and go, I want to produce that, in somewhere else. But there have been court cases around that. There was the Warhol court case just recently, if you saw that. So that is being tested, but it needs to be worked out, over the next year or two in courts. It's going to be a big thing, right? Because these AI models. If you think about, if you did come up with a situation where all copyright information was not trainable, right? So just think about what ChatGPT would be like without that information, or Stable Diffusion would be like without that information. But it's going to happen, and for music models, it's a big thing. So, music companies they've been attacked for years and years and years by people trying to steal music, right? Napster, how many years ago was Napster? Like 10, 15 years ago. So they are very good at protecting their music, but they're also very good at working out how to license it, right? So what we find when we go to music companies is that they openly say, yeah, great, we'd love to train a music model. We'll give you the data. We can have a revenue share scheme for the creators of the artists, for the artists themselves, right? So, every time a song is generated, then the creators get something back from that. And there are techniques that need to be worked out, like, is it the prompt? It's very easy with like voice conversion models where you're converting to a singer's voice because you can target the singer, give the revenue share back to them very easily directly, right? But with a diffusion model that's blending like millions of styles, so how do you do that? But there are ways to do it. So that's a big thing. And I think video models, music models, like the first big ones we see will probably be the result of licensed data sets. Especially music, which is something that we're working. We've just signed our first big music deal, which is it's only 800,000 songs, right? But that's a licensed data deal where that company will get revenue from every song that's generated using one of those songs. But the problem for us, is also that as an open source company, they've said we don't want that model to be open source. Okay, so we've got to either persuade them to give like 10% of their data, so we can, contribute something to the open source model, or we just buy, we get enough funding that we can just buy, stock photography companies and music companies, and we can just own that data. But that's just not going to work, right? So it is scary because if over the next year, this copyright situation evolves into something that it's impossible to train on that data, then the generalism of the models is gonna take a bit of a hit from that. But yeah, this is a big area that we're trying to work out.
Again, I guess not a new problem.
No,
every industry has gone through it so many times.
Yeah.
A question. Human beings tend to be pretty boring. If you look at the movie industry, we tend to sort of enhance them in all sort of ways, right? And I still love the movie Avatar, for instance. Like, right, all of a sudden there's humanoid kind of creatures. maybe that what do you feel of like the movie industry moving to a complete freedom in that area? So creating all sort of creatures. If you look at the Japanese anime, for instance, like it's amazing what they create, and it's like it's partially scary, partially artistic.
Yeah.
Is the movie industry now, with this new freedom of completely generative AI, maybe letting the humans go a little bit?
The ability of the models to blend ideas is something that is I mean, that's basically what a diffusion model is, right? If you think that every word in the prompt is, you know, being tokenized and being used to guide the sampler, right? So that what you end up with, you know, is this image that has been conditioned on every single token in the prompt. Okay, so if you could imagine this, we have a tool where you can weight different prompts basically that are controlling the model. So we can take 10 prompts and we can put a slider on each of those prompts, right? So you can control the weight of each of those different prompts that are conditioning the image, right? So those could be different types of animal, right? And you could have, you know, 50% lion, 30%, and it's incredibly good at coming up with a coherent image that represents that blending of things. So yeah, totally. Like, I mean, this is the magic of it, right? Is that, like, you kind of in your mind, it's there somewhere. It's not possible, but it's there somewhere. But it allows you to explore those different combinations and blending. So yeah, I mean, doing it with video is kind of a crazy idea, but I'm sure it will happen. I'm sure it will happen. Yeah.
Well, if it happens now in anime, then for sure it's going to happen in this way as well, I guess.
Yeah.
Yeah.
I mean, the technology for video honestly, it blows my mind, because when you first see image models and how photorealistic they are now, like, it's kind of incredible that they are able to create such a coherent image. And especially, like, if you look at the training data, like Lion, which is the open source data set that we use for training Stable Diffusion, the captions, like, we developed a custom captioning model. You know, we recaptioned all of the images, combining them with alt tags. But if you look at them, the captions are not great. You know, you imagine, like, this kind of coherent sentence describing an image, you know, with ceilings and floors and colors and things. And actually, quite often it's just a spattering of words, you know, to describe the image. But somehow, the diffusion model is able to create this incredibly coherent image. And there's something incredible about the diffusion model. But doing it with video, you know, having seen how hard it is to get temporal coherence with, like, iterative transformation on images, to see video models like generating proper physics, like proper movement of objects, like liquid flowing, and the idea that the coherence of that, both in time but also in two-dimensional space, is going to get, you know, as good as it is now for just photorealistic images. That blows my mind. Like, the idea that you'd be able to create fully, like, realized worlds in video, because videos, it's just the next natural thing that humans went to, from still image to moving image, and this is all the same thing is happening with generative AI. So it's totally incredible. Yeah.
Hi, so I have a question regarding the timing, mostly. So until OpenAI released the ChatGPT, nobody really, as a big player, released something like that. Why after ChatGPT was released, everyone released something like that? Is it because they had it already in the house, or is it because they inspired from that? Because it's a different thing, and I'm really curious to see your opinion.
Yeah. So there have been language models. There's a group called Eleuther AI, which have a big open source community on Discord. We've supported Eleuther for a long time. For a long time they were sort of part of Stability, and then we've just spun them out again into a separate organization. But they've been training GPT Neo X, GPT Neo J, different versions of open source models since like 2018, 2017. And there are other language models that go back further, right? Like BERT and these other encoder models that have been around for quite a few years. You know, OpenAI just have been quietly working on data. So they clearly have developed, you know, an incredible data set, which they've been working, you know, curating for a long time. But they also trained, like, the first proper 175 billion parameter model, right? So, you know, when I mean, at that point 2 years ago, where we were seeing convergence on these large models with generalist ability was at that scale. And I think what's coming up now is that we're going to see much more performant models at a much smaller size. So everyone is saying, how do I replicate, the ability of ChatGPT, but without training a 175 billion parameter model, which could be $100 million, right? When you combine the data creation, the training, the RLHF, all of the things that have been brought together to make that model possible. It just rules out even we probably will not try to train a model like ChatGPT size. But there are also already now models like Falcon has been released recently, Gorkano. These are 65 billion parameter models that outperform ChatGPT. So we know it's possible to get the same information, but again, data is a problem. So, the Pile v2, which is probably the best language data set on the internet, it's not of the same quality that was used on ChatGPT. So there's this huge effort just from everyone to kind of combine it. And some people are doing that behind closed doors, right? Because they want to try and own the technology, but we just don't think you can really compete. I mean, like with Google Bard, is a company like ours, 150 people, yes, we have a lot of funding, but are we going to be able to compete with Google? Probably not, right? So what makes more sense for us to try and compete with Google or to train, smaller models that, most importantly, are open source, right? So if a government, wants to put their data, national data into a language model, do they want to do it with ChatGPT? They want to own the weights. They want to own the data. They want to own the model. They want to feel like this data sovereignty, right, and just the national sovereignty. So that's our strategy, basically, is to take these models to a big enterprise, big governments where they just they want to own the weights at the end of it. Lots of reasons why you want to own the weights of the model, but you'll never get that with OpenAI. So there is this huge opportunity and landscape of, to be completely honest, like right now, these like Gorkano and Falcon, they're open source, right? You can go and take one of those models. You can take QLoRa, which is like the latest, really, really good fine-tuning library. And you can create a fine-tuning pipeline for a model that is as performant as ChatGPT. And you can load it, you can run it as a service in Amazon. This is not an incredibly complicated thing to do right now. So I think there's a huge potential just like right now for people to launch companies just providing fine-tuning services, right? There's a huge opportunity there right now.
Just following on the previous question, so you mentioned about government using these kind of models and the ownership of data. Do you feel like AWS Bedrock will become the answer for that, or do you feel like that's still quite limited?
So we just launched, we partnered with Bedrock, and then we just launched, they've done a preview month basically where, and there's a few components to it. There's basically like API as a service, where they just handle all of the scaling. So you put the model in and you kind of get an inference endpoint, and all of the stuff around the scaling, they just take it under the hood. And there's also a training service which allows you to fine-tune and train foundation models, which we haven't really explored yet. Bedrock is kind of being developed as it's being released. So AWS is literally like, they're trying to do this as fast as they can, and there's definitely stuff around it that's not been done yet. But they are a major player, right? And they're a major player in terms of the GPUs. So they have a huge number of GPUs, which, there are other companies, so Google has like Vertex, which is a little bit different. It's more of a kind of ML framework as opposed to a foundation model service. But I can't think of many other companies like AWS that are doing proper foundation model platforms and trying to just build like one level up. AWS do this with a lot. They have 500 or 600 different software services in AWS. It's incredible. Like if you look at the library of, and Bedrock, is just like one of those, but they're trying to build this new infrastructure level, above the compute that basically is going to provide the different way for all these generative AI companies to come and provide their models. So, yeah, you could launch quite easily the service I just described as fine-tuning. You could launch that on Bedrock and provide that at scale very quickly, and it would take away a lot of the hassle for you. I don't know. There are other companies that are doing Similar things as like, there's like Mosaic, Bento, Octo, ML, some of these companies, but they're just not at the scale that AWS is. So I do think Bedrock will be big, yeah. Yeah.
Okay. I think we're sort of done through the time, but maybe one more question. If you have, any of you have a...
Burning question.
Well,
Cool.
we exhausted the subject.
Thanks, everyone.
Been very clear. Very exciting subject. Thank you very much.
Cheers. Thanks a lot.